Okay, in this example, we're going to graph the rational function f2 here. First, step 1, find all vertical asymptotes and sketch them with a dotted line and label them. The vertical asymptotes, remember, come from the denominator. So we need to factor this. X plus 3, x plus 3. And we find out there's only one vertical asymptote at x equals negative 3. So we go down. We find negative 3, 1, 2, 3, and we sketch the vertical asymptote. Label it, x equals negative 3. Okay, step 2. Find all horizontal or slant asymptotes and sketch those. Remember, the horizontal come from comparing the degree of the numerator and degree of the denominator. In this case, they're the same, so we use the leading coefficient over the leading coefficient. Y equals 1 over 1, so the horizontal asymptote is y equals 1. We go to y equals 1 and we draw on our horizontal asymptote. Okay. Step 3. Find the y-intercept if possible. Basically, put f of 0. Evaluate f of 0. So, change colors to green because that's what I'm going to graph it in. I put 0 into this function. Let's clean that up. Okay, 0 into this function looks like this. F of 0. 0 squared is 0 minus 2 times 0 is 0 over 0 plus 0 plus 9. 0 over 9, right? Well, that's 0. Looks like 0 in gives me 0 out. That's the y-intercept. So we're across the y-axis. Step 4. Find the x-intercepts by solving f of x equals 0. Okay. Now this, over here, we're going to let this equal to 0. Okay. So I go over here and go 0 equals x squared minus 2x over x squared plus 6x plus 9. Okay? Now what we can do here is, remember, to solve for x, you need to multiply by the LCD. So the LCD is x squared plus 6x plus 9. So I multiply on the left by that, right? See? I multiply on the right by that. I'm running out of room to write it, but I write it in there. Well, on the right side, they're going to reduce. On the left side, they're going to equal 0. This times 0 is 0. So I get 0 equals x squared minus 2x. Now I need to find when is this 0? Well, that's a factor problem. Factor out the x. Alright, then I have my two solutions. When x is 0, which I already have, it gives me 0. And when x is 2, I don't have that one. That's a new one. So I got to put that one in. That's my x-intercepts right there and my y-intercept right there. Okay, let's clean this up a little bit. Alright, let's go to the next step. I've got the x-intercept. Now I need to decide whether the graph will cross the horizontal asymptote I have. So I let f of x equal that horizontal asymptote and I solve. So the horizontal asymptote is 1. Okay? So I let this be 1. Let y be 1, which is that. 1 equals x squared minus 2x over x squared plus 6x plus 9. Now I multiply both sides again by the LCD, which is this thing here. So I have x squared plus 6x plus 9 like that. And then x squared plus 6x plus 9 like that. But they cancel here, and they make just this whole thing over. So it's x squared plus 6x plus 9 equals x squared minus 2, right? I subtract an x squared from both sides. 6x plus 9 equals to negative 2. X, oops, I forgot an x there, negative 2x. Better put that in there, right? I was hiding here, negative 2x. Then I subtract a 6x from both sides. 6x, 6x. 9 equals negative 8x, and divide by negative 8. Negative 9/8 equals x. Alright, well, what does negative 9/8 mean? It means that when x is negative 9/8, the function will equal 1. Well, negative 9/8 for the x, go over 1, that's 8/8, go just over a little 1/8 more, which is right there, right? And then it's equal to 1, so right there. That's what it means. That's where it crosses the horizontal asymptote. This graph crosses the horizontal asymptote. Okay, now we want to go to the next step. Basically, we want to see where is the other parts of this graph. Okay, let's do that. Step 6 says plot selected points. All right, so the points we're going to plot are over here and over here. Well, we have enough information to find out what's going on here. It's got to go through this point, this point, this point. So it's got to go towards the red line, right? So it's got to go towards the red line. So down like this, it go through that green, through this green, and then it's got to come down. And how far does it go down though? So we better find out. Let's put 1 in here. So put F2 and then put 1 inside there. We get 1 squared is 1, minus 2 times 1 is 2. 1 squared is 1, plus 1 times 6, plus 9. So on the top I have negative 1, and on the bottom I have 10/16. Well, it doesn't go down very far, so when I graph this, I'm going to come through there like this. Just barely moving, and again go back up, and then it's got to go towards this line again, right? That's what asymptotes do. So it barely scoops down, and then it goes right back up towards that line. Okay, that's that side. Now let's find this side. If I put in negative 1, negative 2, negative 3, negative 4, if I put in negative 4, we will get a point on the graph. So let's put in negative 4. F2 is the name of the function, right? So I put in negative 4. This is what happens. Negative 4 squared, 16. Negative 4 times negative 2, positive 8. Negative 4 squared, 16. Plus 6 times negative 4, negative 24. Plus 9. Alright, so on the top we have 24. In the denominator, 16 plus 9 is 25. Minus 1, or minus 24 is 1. So when you put negative 4 in, you get 24. That's way up here. Okay, so it's way high up there. Then what happens, let's put another one in. Let's put negative 5. So, negative 5. Negative 5 squared, 25. Negative 5 times negative 2, 10. Negative 5 squared, 25. Negative 5 times 6, negative 30, plus 9. So I have 35 over, that's negative 5 plus 9 is 4. 35 fourths, which is 8.75. Okay, I can graph that. Negative 5, 1, 2, 3, 4, 5, 6, 7, 8.75 right about there. Okay, well, we can grab another point, but we kind of know what's happening. This is going up, and this is going down. So just sketch it the best we can. Goes up and comes down like this. Okay, there's my graph. That's a pretty good sketch. It's going through all the right points. I got a point over here. Let's look at the computer graph. So here it's perfect, right? It's all nice. It goes through this point right here, negative 8/9, 1, right? Then it goes through 0, 0, and 2, 0. I had all those points. And it dips down just below, barely below, and comes back up and goes towards the asymptote. Goes through my point negative 4, 24, and it goes through the point negative 5, 8.75, right? So that's how you graph this rational function f2.